Hello everyone. Um, Thank you for watching this video. My name is Sagar. So I'm a software engineer. So today, I created this short video to just explain what is race conditions, which is a very famous question in interviews, and also it's a very famous concept that every programmer should know, irrespective of whatever language they're using. So before starting race condition, uh, first we need to understand a concept called atomicity. So what is atomicity? So for example, if you have a thread and in the thread there is instruction where the value of a particular variable is 10, let's say x equal to 10, and the thread is doing x equal to x plus 1, that means the output should be 11. So what happens under the hood when when the thread try to update the value of x? So there it actually executes three instructions. One is first reading the value of x from memory to the CPU register, we call that reading. Then updating the value of x inside the CPU register based on the operation. So here it's like x equal to x plus 1, that means 10 plus 1 equal to 11. Then modify. So modify means writing back the value from the CPU register to the memory location, that is where x is located. So that means it will update it to update the value of x to 11. So basically it's called read, update and modify operation. So when these three instructions are executed without any interruption, as a single indivisible unit, we call that as a atomic operation. Okay, so now this is now you understand what is atomicity, or how x equal to x plus 1 happens. So if at any point of time this operation is disturbed by someone else, or then there will be some problem. Now what is that problem? That problem is called race condition. Now let's take an example and increase the number of threads. Now the number of threads are 2. So we have thread 1 and thread 2, and the final output that we are expecting is thread 1 will update x by 1 and thread 2 will update x by 1. So the final output should be 12. That's the expected behavior from this code snippet that we are expecting. But what happens is, let's say thread 1 is scheduled and thread 2 is also scheduled, but let's take thread 1 is scheduled. So what thread 1 will do, it will read the value of x from the memory to the CPU register. At the same time, when thread 1 is updating the value of x in the CPU register, not in the memory, so it's in the update stage, thread 2 is also scheduled. For example, it's a multi-processing system with multiple processors. So what thread 2 will do is, thread 2 will read the value of x, and the x value is still 10, and it will read the value of x from the memory location to the register, and then it will try to update. At the same time, thread 1 is also updating inside CPU register, not inside memory. Now let's say thread 1 is done updating the value inside CPU register, and then thread 1 will update the value that it has in the CPU register to the memory location x. Now x value is updated to 11, but thread 2 is also updating the value of x inside its CPU register, and the updated value is 11, right? So once it finished, so thread 2 will also modify the value of x in memory to whatever it has computed inside its register, and the value is 11. So what is the output? It's 11, right? So this is called race condition. So basically, when you have a global resource, so the state of that resource cannot be guaranteed if multiple threads try to update or try to modify the state of that particular resource without waiting for each other, without having any mechanism to talk with each other. So this is called race condition, where your read, modify and update instructions are not atomic. So that is called race condition. So in simple terms, if someone asks what's a race condition is when two threads or two processes try to update the state of a resource. It can be a variable, it can be a memory, or it can be a file, or it can be anything. Try to update the state of a particular resource um, at the same time, and the update operation is not atomic, then the output of that particular operation is going to be undefined, and that's called race condition. So that's all. Thank you for watching this video. I hope you like this. So this is my first video, so I'll try to improve few things going forward. So I'll try to upload small videos of such concepts like race condition. Then in the next video I'll upload, I will explain like, okay, now you understood about race condition, what about preventing race condition, what are the techniques in Linux or in the operating system available for you to prevent the race condition. Those things I will explain in the next video, small video of less than 5 minutes. So that's my target. Actually, I wanted to create videos which are less than 5 minutes so that someone can quickly go through the video and just understand, okay, what is the core concept, instead of reading and going through a lot of books. Yeah. Thank you so much.